So what I'm going to do is I'm going to try and solve this radical equation. So the first step of any radical equation is to get the radical by itself. So in this case, this x has got to go. So I'm going to add x to both sides. So I get the square root of 6x plus 19 is equal to x plus 2. And then I'm going to raise both sides to the power of the index. Now remember, if there is no index, then it is a 2. So I'm going to square both sides. Now on the left-hand side, squares and square roots kill each other off, so I get 6x plus 19. But on the right-hand side, I have a binomial, or I have two things that are being squared. And the way that you have to do that every time, is to FOIL it. So I'm going to take x plus 2 and multiply it with itself. So if I do this very quickly, I get x squared plus 2x plus 2x plus 4 with my like terms right here. So what I'm going to get on this side, x plus 2 squared, is equal to x squared plus 4x plus 4. It is just this guy. So now I have a pretty normal equation. Anytime I see that my answer has an x squared, I want everything to jump ship to this side. So the x squared is on the right-hand side. All of this stuff has to move over. So I'm going to subtract 6x from both sides, and I'm going to subtract 19 from both sides. So I get 0 equals x squared minus 2x minus 15. And from here, it's pretty normal factoring. So what I'm going to do is I'm going to find a pair of numbers that multiplies to negative 15 but adds to negative 2. And I am going to skip all the steps of factoring, but the idea is the same. I am going to end up with x minus 5, x plus 3. There's a video earlier on how to factor, so I'm not going to go through all the steps. Now, if I do this, my solutions are to set each of these independently equal to 0. So I get a solution as x equals 5, and I get a solution as x equals negative 3. Except with radical equations, there is an extra step in that sometimes there are such a thing as extraneous solutions. So what I need to do is I need to check these for being extraneous. I'm going to check 5 first. So in the original equation, before we did any math, everywhere there is an x, I am going to put 5. And I'm going to see if it actually equals 2. So I've got negative x plus the square root of 6x plus 19. And I hope that it equals 2. Let me just put a quick question mark there to say we're hoping it does. So I'm just going to finagle this side until I get it. So I've got negative 5 plus the square root of 6 times 5 is 30 plus 19 is 19. Or I'm sorry, 6 times 5 is 30 plus 19 is 49. And I hope that is 2. Well, the square root of 49 is 7. So I have negative 5 plus 7 is 2. And that is a true statement. Negative 5 plus 7 is actually 2. So, happy face. This actually works. Right? It does not say that 7 or 5 or 2 work. It says that this 5 right here is a solution. We plugged in 5, therefore it works. I still have to do the second one, though, because they have no bearing on each other. The first one working says nothing about this guy working. So we're going to do the same thing. Everywhere there is an x, I am going to plug in negative 3. So I've got negative x is equal to the square root of 6x plus 19. And we are going to hope that it is 2. Oh, I apologize. This should be a plus right here. So we're going to simplify it through again. So negative 3, that is 4. Or I'm sorry. I'm making a lot of mistakes on this one. Negative 3 is positive 3 plus the square root. 6 times negative 3 is negative 18 plus 19 is positive 1. And we hope it's 2. The square root of 1 is 1. So 3 plus 1 is 2. Now that is a false statement. 3 plus 1 is actually 4. So this does not work. Sad face. And therefore I am going to x out the solution. The only solution to this equation is x equals 5. The extraneous solution, the solution that lied to us, was negative 3.